I'm going to begin the recording. Um, all right. So it is 8:05. So without further ado, so that we don't kind of bite into anybody's time and ability to show off their projects, we'll get started now. So first off, we have Braden, who is going to be showing off his ball tracking robot. Braden has demonstrated a unique mix of creativity and technical skill throughout his project. He has designed and fabricated a custom 3D printed mount for his ball tracking robot components, tailoring it perfectly to his own vision. He's going to explain further about that on his own, show off his design. Going further, he's also implemented a gesture recognition script and is able to use that to control his robot based off of where his finger points. This not only shows off his engineering expertise, but also his innovative mindset that helps tie both software and hardware together seamlessly. Without further ado, let's have Braden take it away.
Hello, everyone. It does work. Right. Hello, everyone. My name is Braden. Daniel gave a quick overview about me. So I go to Naperville North High School. I'm a rising senior. And here is my project. So this is the ball tracking robot. As you can see, there is the custom 3D print, which I'll get into in a second. Yeah, I'll get to in a second. So the first thing I'll explain is the base project, which is the ball tracking robot. Basically, it takes the red ball, processes it in the camera right here. So it's like a camera right there, and then rotates itself using PID, and then moves forward and backward using the ultrasonic sensor to deter to get a specific point away from the ball. And then I guess to go into some of my modifications, the first modification I made, as Daniel explained, is this 3D printed mount. It uses a lot of curves, as you can see. This is very different than what I usually design. And then on the robot, you see it's right here. It's like holding the printer or holding the Pi, the breadboard, the camera, and the ultrasonic sensor. So here are some iterations I went through, some that didn't work, a bunch of these printed. So the second modification I have is actually, as Daniel said, the gesture control on my robot. Basically, it takes input from my hand and then converts that from my computer, processes it on the computer, runs it through a WebSocket. My Pi picks it up, and then the robot will rotate, left, right, forward, backward. So I have video demonstrations of both the robot and the gesture, so the base project and the gesture. So right now I will share my screen so that you can see it. So this first video is from my milestone 2 video. Basically just demonstrates, you see here, let me make sure I can see everything. Can everyone see my screen?
Yep,
Just want to
that's good.
confirm. Yeah, okay. So as you can see here, the robot is searching for the ball spinning in place, sees it, drives really fast, and then adjusts, makes some final adjustments, and then it's done. And then I move it over a little bit, and you can see that it still adjusts itself. So the second video is of my gesture control. So basically, you will see here that you can see the nodes on my hand, and the robot goes out of frame a little bit. You can see how it kind of works here. So it goes forward, backward, left, right, and yeah. Okay. So those were the 2 video demonstrations. That pretty much summarizes my project. So to go into what I've learned, I learned a lot from this project, as you can kind of see, from computer vision to then WebSockets, and then like using those nodes on my hand to like control different parts of my robot. Like I definitely explored much more into software engineering, where we're in robotic. I do a lot of robotics. I usually do a lot more mechanical engineering, designing parts, things like that. I chose Bluestamp engineering because there are other programs out there that are outrageously expensive. They're like $12,000, and that is way too much in my opinion. And I think for what it's worth, this project or this program is also like not invasive on my schedule, right? I'm a senior next year, and so I'm not going to have the time. Or like if I went to, a program in California for 4 weeks, right? I'm gonna like my summer schedule, like the things I need to get done are gonna get really messy. Yeah, any questions?
How does the
No question.
WebSocket work?
Okay, so the WebSocket basically has a server and has a client. So the server is actually my Pi, not my computer. The client is my computer, and so then the server they communicate with each other through a host and a port. And basically, information is sent. In this case, only from my computer to my robot. So it's just hand length and angle that is sent to my robot to the Raspberry Pi. And it's sent through a JSON object. That way, I can send multiple different attributes, or in this case, variables, or which are just variables rather. And that way, you know, I can go from computer to Pi and like transmit information.
I have a question.
Hmm.
Hey, it, I assume for all these demos, your client is on the same network as your Pi is, like you're connected to
Yes.
your home Wi-Fi. Can you control
Yes.
it from anywhere in the world, or is
No.
it
Right
only
now,
on
you
your internet?
cannot. No, you can't do that right now, unfortunately,
Okay.
because it relies on the Wi-Fi.
Okay. So
Um,
anything that's on your Wi-Fi can control it, but you can't be
Yes,
in,
yes. Because I use on my computer, I have the IP address of my Pi, but that's from the Wi-Fi,
I see. You'd have to
not
do like port forwarding, or you'd have to do something to make that connection.
something really fancy. Yeah.
Yeah, okay. Cool.
I have a question. Can you
Mhm.
explain what is a PID controller?
Okay, so PID controller is stands for proportional integral derivative. I'm going to leave out integral because it wasn't too relevant for this. Basically, it's just a more smooth way to go from A to B. So let me just I can like draw it out probably. So it's like oh picture marker doesn't work. So
You
you
might
just
not have
have
time to draw, but
yeah,
yeah.
yeah, it's fine. All right. Basically it just goes from it takes a target value, takes a current value, just tries to get to the target value. Proportional uses a magnitude times the error. Derivative uses magnitude, a different magnitude times the change in error. And then if you combine the two, you get P plus D, or it's supposed to be P plus I plus D, but we don't care about I. And so then that is then your speed. That's how PID works.
Awesome. All right. Um, about 30 seconds left for one final quick question. Is anybody? If not, we'll move on to our next student. So thank you so much, Brayden. That was a great presentation. Next up, we have Steven. So Steven here, his project was an LED flow simulator, but he has pivoted a lot due to some technical issues that we ran into initially when the code that was built and on the GitHub repository doesn't actually like run on the devices that we have. Um, but he's like been incredible throughout this entire time. So he has like showed a remarkable self-driving capability throughout the program. We pivoted quickly to find a new direction. We ultimately building something that is much, much more successful. His resilience and independence has been incredibly inspiring to watch, and it's been amazing to see how much progress he's made on his own as well. Without further ado, let's have Stephen introduce his project.
And hey, Braden, if you could turn off screen share, that'd be great.
Hello, my name's Steven. I'm going to be an upcoming junior at Glenda Dawson High School. This is my project. So right now it's a clock, and then using buttons on the side, I can switch it to different modes. So this is the flow simulation mode that I was originally supposed to do. This is the first step of it, and the second step was uploading an image, but the code was faulty, so I couldn't do that. And then this is one of my favorite modifications of this. It connects to an API on Valorant that sends you put in your username and then it sends back your rank and how much RR you lost, right now I have it as 10s, and he's radiant and had lost 23 IR. I also added another mode. Oh, I clicked the wrong button. But I added a fourth mode, which was supposed to connect to an ESP32 and with a sensor connected to the ESP32, show the data on the screen, but I couldn't have two. I was originally supposed to use MQTT, but that didn't work because I needed to use two Wi-Fi antennas, but there's only one in here. And then I switched it to using an API like the Valorant display. But sadly, the sensor I think was broken, so I couldn't even get it to work if I even plugged it into the screen. There were many difficulties with making this project. This was one of my biggest headaches because I couldn't connect to the Wi-Fi module no matter what I tried. So then after like 2 days of debugging and then still not working, it was just old software. This taught me like that most things have like a solution, even though it might not be the one you're thinking of right now. Also, I had another major problem, which was on my old microcontroller that I had on this Matrix had only 256 kilobytes of RAM, and I couldn't do much because it kept crashing because there wasn't enough memory on it. But now I have the newer version, which has more memory, and then it can make me switch between tabs more. On the old one, it would crash after switching between like one tab. Why I joined Bluestamp was because this was like around winter, spring. I knew that summer would be very boring if I didn't find myself a project to do. And then I stumbled upon Bluestamp and it was like this aligns with what I want to do this summer, which is like engineering and then a lot of like I guess STEM focused. And then the reason I picked this project was because I was in the room where everyone else picks projects, and then everyone was picking a car or like I don't know the mechanical arm, and I wanted to do something different. So I was just scrolling the pages, and this caught my eye. Any questions?
How does the Valorant thing work? Like, how do you access the ranks of someone?
So I'm using an API, and through the API, you send your username and the name tag, I think it's called, and then you just request, and then it sends back the information, then make it look nice.
Any other questions? No. How about Steven? Could you tell us a bit more about how you're actively communicating between the ES or what your intended modification was supposed to do to communicate between the ESP and your device? Because these are two separate devices, right?
Originally, was supposed to use MQTT protocol, which is using a network where you send information to a server, and then you use, I guess, the matrix for this example, and you pull from that server. That was what I was originally wanting to do, but I have only one antenna, so I couldn't do that because it uses a different way to access the internet than the one the API does.
Like, what was your favorite part about in creating this project?
Probably seeing the Valorant tracker work because it took me like 4 days straight coding, so and debugging.
You said you deviated a lot from the original project. What was the original project supposed to be?
The original project was supposed to you upload a bitmap file, and then it has a flow simulation like of the bitmap. So right now I have the basic version, which is just two dots, and you have to like manually set like what the dots are.
Hmm. How does the physics for that work? Like the flow simulation?
A lot of math that I didn't do.
Yeah. Don't need to reinvent the wheel, right?
Mhm.
All right. Any final questions? All right. Thank you very much then, Steven. That was a great presentation. All right. Next up, we have Tony. So Tony's project was the self-driving car. So we Tony was able to jump directly right into the robotic projects, successfully building out both the line following module as well as completing the self-driving car with relative ease. What really stood out was his desire to go beyond the basics. He's exploring upgrades like adding mechanism wheels and integrating Bluetooth control as well. Even though we've hit quite a few technical bumps along the way, such as ultrasonic sensors not working, etc., his curiosity and determination on his project has been really, really exciting to watch. So without further ado, let's have Tony kind of demonstrate his project and show us what he's been working on.
Hello, I'm Tony, and I'm part of KIPP NYC High School. I chose to do the self-driving car because I wanted to help people who can't drive or have disabilities reach their destination faster. So my self-driving car has an ultrasonic module which uses sound to detect distance. It has a transmitter which sends sound waves towards an object, and once it sees it, it uses the time the sound traveled to measure the distance. It also has infrared lights and a line following module. Um, Currently, I'm working on the mechanism wheels, so I can't really show you an actual demo, so I'm gonna show you a video. So one of the reasons why I decided to join Bluestamp was because I wanted to show my community how technology could improve this world. And like I wanted to also like be part of a community in which I could feel welcomed. Um, some of my failures I had was the old Bluetooth module since I wasn't able to actually make it work, but currently I'm trying to debug it. The ultrasonic module wasn't really working as Daniel said, so I had to get it replaced, and thankfully now it's working. The mechanism wheels are fine, as you can see over here. I currently have the motors installed. The infrared lights, I'm still working on it, and I still have to install the ultrasonic light. Any questions?
Awesome. Are there any other questions? Are there any questions that other students want to ask? Any stakeholders?
If
What
you
is the
were to,
Bluetooth? Oh, you go first. Yeah.
okay, if you were to somehow turn this into like an actual product, what kind of changes would you need to make?
I would want to make a GPS module since if it were an actual project, people would need to know where to go instead of just wandering around.
And then how does the Bluetooth module work?
So it's like wireless. The Bluetooth module, I was gonna use it for like a wireless controller. So basically, it's like
Mm.
a transmitter and a receiver. It transmits messages from a Bluetooth term to a Bluetooth terminal, and it receives it to a serial monitor.
Okay.
What was like I guess, favorite part of this?
Being able to see how many modifications I was able to do today.
Like, what would you say was your favorite modification?
The mechanism wheels, since they're omnidirectional wheels.
That's really cool. Are there any other questions?
What's the biggest challenge you faced when making this project?
Um, I had many challenges, but one of the biggest challenges I had was making the Bluetooth module work. I kind of took like 2 to 3 days on trying to fix it, but I never could have fixed it, so I decided to work on something else.
Yeah, that's all good. Yeah, sometimes we just have to pivot to things when our things aren't working, but that's just part of engineering, right? All right. Um, thank you very much, Tony. That was a great presentation as well. You did very good work. We'll move on to our next student, which is Ashwin. Ashwin took on the challenge of building a custom chess clock and approached it with remarkable patience and persistence. So we got off to a very, very great start. Um, Initially completing a lot of the hardware tests. But he devoted a lot of time. Eventually, we got to the programming step, and he devoted significant time in learning how to actually program the clock from the ground up, not just copying code off of GitHub, and ultimately solving most of the technical challenges on his own. So now he's taken his project a step further by designing some custom CAD files showing his dedication and detail and his dedication to detail and his willingness to expand his skill set. Without further ado, let's have Ashwin show off his project.
Hi, my name is Ashwin. I go to international school, which is a 6th through 12th grade school, and I am currently a rising junior. For my project, I chose the chess clock. Here it is. It uses this rotary encoder here. When I turn it clockwise, both of the displays will increment by 30 seconds. Can't quite see a second one, but here it is, and here's the other one. You turn it counterclockwise, it'll decrement by 30 seconds. When I push one of the buttons here, it'll decrement the time. Oh wait, nope, hang on. When I push the button on the rotary encoder first, it'll lock the time and prevent it from being changed by the rotary encoder. When I push one of the buttons on this breadboard, it should start decrementing the time by 1 second. And when I push the other button, it'll decrement the time on the other display. Here's the first display for reference. And it'll continue on, it's a chess clock. Press the button, it'll lock 1 time countdown. And one thing which I cannot show off in this presentation due to it not being long enough is that when one of the times reaches 0, the buzzer will go off for 3 seconds and then turn off. One modification I made, which you probably already saw, is that I added an external power source, which is just this 9-volt battery case with a switch. When I turn it off and on again, it resets it back. They have to set the time again. One challenging aspect that I faced while making the project, as Daniel said, was the code. Uh, I found it quite difficult at first because I kept trying to do too much at once, often because I kept copy and pasting code that I found online, and it often didn't work properly since most of it was not designed to be integrated together. So it took some time for me to realize that instead of trying to resolve all these issues, it would be better for me to just work in chunks. So, like for example, I just started with the display code and ensured that it properly displayed numbers. And from there, I ended up working through all the other components, like the buttons and then the buzzer. And eventually, I was able to figure out exactly what went wrong and fix it individually, making it a lot easier for me to work with. As I already said, main lesson that I got away from this was that it's easier to work in parts than it is to do everything all at once. As for why I joined Bluestamp Engineering, it was because I wanted to do something. I wanted to make something for myself. Because I am a part of my school's robotics team doing mechanical, but I don't really get a chance to make stuff that relates to my interests, for example, chess. Such Bluestamp gives me an opportunity to make stuff that really relates to my interests rather than just something for like, I don't know, whatever that season's game is or whatever challenge they have. Any questions?
Have you thought of any like have you thought of any additions that would improve like the general looks of the timer? Like a case for the
Yes,
like
I have. Unfortunately, the CAD is not done yet, so I can't really show it off without it being confusing, but the CAD should be done pretty soon.
What CAD software do you use?
Autodesk Inventor, like, because I have a student license, so I can just use it for free.
Are you gonna publish
Oh,
those solid or the inventor files on your website?
Yes.
Awesome.
another question I had was, can you add delay to the timer? Like, in chess, if you like make a
Mm,
move.
Yeah, I could probably add that in later. Like maybe after like Bluestamp ends.
That'd be cool.
Do you plan on using this for your chess games?
Yeah, all right. I forgot to mention why I picked that project. It's because I've currently misplaced my current chess clock, so I need a new chess clock. So I figured that I should might as well just make one while I'm here.
After you make this project, are you more interested in mechanical or electrical engineering?
I would say mechanical engineering.
Right. Are there any last questions? Nope. All right. Thank you very much, Ashwin. That was a very, very great presentation. All right. Next up, we have Sid. So Sid is also another one of my students that worked on the Raspberry Pi or like ball tracking robot. So Sid came into the program with very strong programming experience, which he used to take on the ball tracking robot to the next level. He's integrated an accelerometer with another Raspberry Pi and developed a socket-based remote control system, demonstrating both his creativity and his technical proficiency. Sid's confidence and skill made it a pleasure to watch him explore new approaches and push the limits of what his robot is capable of doing. Without further ado, let's have Sid demonstrate his robot.
Okay. Hello, I'm Sid. I go to Saratoga High School and I'm a rising sophomore. Here's my ball tracking robot itself. You can see I have camera at the front and then three ultrasonic sensors, and there's a breadboard and the power over here. And I also have my controller. This is a modification that I add. I have over here, there's a Raspberry Pi Zero and there's an accelerometer, and there are three buttons over here that you can press on and then RGB LED. So here I'm gonna show my video. So on the top left is the live feed that it is in camera view, like what the camera can see, and at the bottom left is the video of the robot moving, and then on the right is the controller. Okay, I'm gonna start the. Okay, so currently it's in. Wait. So I have a button that can switch between manual mode and automatic mode, and in the beginning it's default as the as the manual mode. So I can tilt the controller to control the robot, and I can change the color that the robot is gonna track when it is in automatic mode. And currently it is tracking the black object, and you cannot display black light because it does not exist, so I just turn the LED off. And now I switch it back to manual mode, and I switch it to blue so that it's gonna track the blue object. Like that. I can like draw boundaries around the blue object that I see. Yes, and then it's trying to center the object. And then now I switch back to manual mode and have it to track the red ball. The live feed also display the mode, the speed, and the color that it is tracking. Okay, so I move my robot again using manual mode, and then switch to automatic mode, and the robot can center the red ball and then go to a set distance that says, which is around 20 centimeter. Yeah. And then, so the base project is to track the red ball. As you can see in the video, it is most accurate when tracking the red ball. It uses image segmentation to identify the object it should track. It then draws boundaries around the object, which is called the contouring, which is a technique in computer vision. And the average of XY values on the contour will be the center of the object, which is what the robot is going to track. And the robot can calculate the offset of the object from the center of the camera and determines how much it should turn. And there's a PID controller that calculates how much a robot should turn based on the offset value and the previous offsets so that it can adjust itself and then make it like really smooth. And for the modifications, I added a controller over here. I'll show you again. It's connected to a Raspberry Pi Zero over here. There's an accelerometer, this little thing, that can determine how much the controller is turned, how much I tilt it, and then send the acceleration in X and Y axes using sockets. So a web socket is a communication between a client and the server. So in this case, the controller is the client that is sending the messages to the host, which is the robots. And I have a RGB LED that can display the color that the robot is currently tracking. The reason that I joined Bluestamp Engineering was because I want to give myself a challenge and explore different aspects of engineering over the summer. I had lots of experience with programming, so I chose the bull tracking robot as my project because it involves lots of mechanical and electrical engineering, which are both really new to me. Through this project, I learned a lot about wiring using breadboards, RGB LED, accelerometer, and especially computer vision. I learned a lot about how camera track different objects using like image segmentation, contouring, centroid, and calculate and do algorithms. The biggest challenge that I faced was that I couldn't connect to the Raspberry Pi Zero with VS Code. And I think it was because that VS Code has too many files. Like there are many built-in debugger, like the Python debugger. Like the files might be too big for the Raspberry Pi to process. So then I decided to use the built-in terminal on my MacBook, and so I needed to use the Nano editor on the terminal, which is really hard to use. And I need a like I wrote my codes on the VS Code first, and then I can copy it to the Nano editor because Nano editor is really hard to edit, and so I can run the program on my controller. Any questions?
So Sid,
In the
I know
interest of
you
time, just we'll only take about 2 questions, just in the interest of time. But yeah, go ahead.
so Sid, I know you just got the Pi Zero to work today. How did you code everything else like um independently or like asynchronously um and still get it to work? Like how'd you test all of it and see make sure it works?
So because I got the SD card for my Raspberry Pi Zero last time, so I tried to connect it for a long time and I couldn't. So I decided to write my code for the controller on my Raspberry Pi 4 first. So I created a new folder. So the code is over there, but I cannot test it. I couldn't test it until today. I figured out that I can use the built-in terminal. So I haven't tested it at all before today, and it turns out pretty good.
That's very impressive.
Yeah.
We have time for one last question. Otherwise, we're going to move on to our next student.
Daniel, can you really quickly send me the my milestone video
Oh,
because
yeah, yeah, we'll do. We'll do. All right. In the meantime, we'll have Julia introduce the next student.
All right, so our next student is going to be Ritvik. He did the Lunar Lander project and he completed his project very quickly within the first few days, getting the base model of the Lunar Lander working. And then he undertook several substantial modifications, ranging from getting the video to render on the Raspberry Pi, optimizing the Raspberry Pi code, and even a very intensive one relating to creating a drag and drop lunar lander environment that ultimately involved working with a substantial source code base totaling over 1,000 lines, I believe. And he really dug deep into the source code, understood all the libraries that were imported, and did an awesome job bringing his custom environment to life. So I will turn it over to Ritvik to tell you more about that.
Hi, my name is Ritvik, and I'm an incoming senior going to Doherty Valley. So I just wanted to, I think, share my desktop. So I guess what I wanted to show right here was basically the main part of the model. So this lander is technically using a DQN, which is Deep Queue Network Clearing model to learn and be able to land properly. So here you can set multiple things like the learning rate, batch size, buffer size, and multiple other hyperparameters to try to tweak the network and make it more stable. So it also uses double neural network layers to help it get better. And so yeah, my first modification was mostly just building and trying to customize and change these hyperparameters. However, my other modification was actually creating a drag and drop. So if I just run this over here, and takes about 10-20 seconds for the drag and drop to, yeah. So you can just drag, drop shapes, and when you got like three options to choose from, as you can create your own environment and you can place them basically anywhere as long as they're not outside of the screen. So once you click the X, it saves and then it starts running the program. So meanwhile, I had some other thing. So this was like the pre-training episode before it didn't even land. So it was just stuck in the air before any training at all. And then after about 20,000 episodes, which technically isn't a lot, this took like maybe about 3-4 minutes to run. So this is like how it goes after 3 to 4 minutes. So give it about like 20 minutes and it should be running basically like trying to optimize the landing path and depending on the gas, like how much fuel it has and also not colliding. So yeah, that is my project.
Awesome. Does anyone have any questions for Ritvik?
How does like when you customize the environment, like with the circle, the square, how does that work?
So basically what I did, actually, yeah, should probably scroll all the way up. I first of all, I just had a class that was of shapes, and they're technically all objects of class shape. So they all have a draw feature. And this is actually a Pygame thing. So I just created a quick Pygame script which lets you drag and drop the polygons onto. Yeah, it's like you can see this mouse button down and collide points. So every time you click on the top three shapes at the top left, it technically creates a new one which you can drag.
So then do all like the coordinates of the borders of the shape get like saved somewhere and then like how does that work?
Yeah, so after that, they're technically saved into this. This is like the list that it's called shapes and it stores all the shape objects. And after that, they get passed down into this giant custom environment creator, which I put um somewhere into here. You can see it creates the polygon fixtures and it also ends up creating the actual static bodies so that it has collision. And then after that, it also creates like so you can see the shapes. It creates like the Pygame on that as well.
That's very cool.
Yeah, most of it was just like from the original one, but I had to tweak a few things. So yeah, in the render thing, here is where it draws the polygons.
Awesome. All right. Does anyone have any other questions for Ritvik? If not, or Oh, I think I saw someone on mute.
Oh, I see that you have Xcode and IntelliJ installed
Yeah,
on your Mac.
yeah, I do.
Do you wait, so after this project, are you more interested in software or hardware?
I mean, this 2 years project was like completely software, except for like the first day where I was just like trying to put together the Raspberry Pi. But apart from that, it's software. Like I like software more. I feel like you can do more in software, but also technically the other program did finish running. So we can also look at that. This is like a pre-training. It's kind of wobbly. And then this one, I think ends up crashing, but can run kind of fast. Give it like a couple 100,000, a few 100,000 more episodes and about 20 minutes and it should be running pretty good.
Oh, okay.
All right. Well, thank you, Ritvik, for an awesome presentation. And if no one else has questions, I'll turn it back over to Daniel to introduce our next presenter.
All right. Next up, we have Kyun. He's showed incredible patience and dedication, especially in the face of a lot of pretty perplexing bugs. And he's approached these challenges methodically, taking extra care with each step to ensure that it was done right. And his attention to detail paid off as he finally was able to install a custom servo mount for his robot, further enhancing its capabilities while also learning valuable lessons about mechanical design and integration. So without further ado, Kyun, please take it away.
Hi, I'm Kyuyan, and I'm a rising sophomore at Lee High School. My project was the ball tracking robot. It's controlled by a Raspberry Pi that is SSH into my desktop. It's powered by a battery pack and two motors. It uses the ultrasonic sensors mounted at the front and the Pi camera to track this red ball and steer itself towards it. I unfortunately cannot demonstrate it live, but I can show you a video. So here is my code, and here's a live feed of the PyCam. So as you can see, it makes an outline around the red ball, and it shows the center of it, and also displays the numerical offset of the ball from the center of the screen. So the robot steers towards the ball by first having the Pi camera uh, use a image recognition software that that figures out the center of the red ball, and depending on the amount of offset there is, it uses a PID control system, which stands for pro proportional, integral, and derivative. To so it uses the three factors to change the turning speed of the motors so that the robot correctly steers towards the ball. And when the robot gets close enough to the ball, the ultrasonic sensors detect it, and the Pi sends a message to my desktop saying that it has reached the ball, and the code stops. Through this project, I learned more about the software and mechanical aspects of engineering. I picked this project over other projects such as the smart mirror because unlike the smart mirror, which is mostly software heavy, the ball tracking robot had a good balance of both mechanical and software engineering. After finishing this project, I now know that I find the mechanical sides of engineering to be more intriguing, but I'm still open to learning more about the software side. I joined Bluestamp engineering because there weren't many other options for engineering summer camps that allow me to pick my own project and have more responsibilities rather than just being spoon-fed information. Any questions?
I think like what was the software component to this project? You said there was like half and half-ish.
Yeah, so for the software part, let me share my Visual Studio Code real quick. So this is my main code, main program, and this is the function that defines the PID controls. So the most difficult parts of the program were figuring out the PID controls and getting the Pi camera to send a live feed to my computer. When I first tried to get the live feed to my computer, I somehow got a segmentation error, but after some debugging, that was eventually resolved. So yeah,
Are there any
great.
other
You got any
questions?
questions?
Yeah, if you had another 3 weeks, what would you do with this project to make it even better?
Oh, so so I was currently working on a modification to have the servo motor pan and tilt the camera so it can help the robot find the ball more easily. But I ran out of time and couldn't get that to work. But I mean, I did get it to work, but I can't demonstrate it now. And I also thought about catting a 3D printed case for the robot to conceal all the wires and the motors. Um, I would also try to add a keyboard control mechanism so I can just use the WASD keys on my keyboard to
Hmm.
control the robot manually.
Nice. Nice.
Okay, we have time for one last question. All right, if not, thank you very much, Kian. That was a great presentation. And we'll let Julia introduce our final student for
All
today.
right, our final student is Gleb. As only an incoming freshman, so one of our youngest students, he was able to take the Infinite Text Adventure project and fully implement a customized role-playing game on his Raspberry Pi with extensive modifications ranging from converting the base project from CircuitPython on the PyPortal to his Raspberry Pi, implementing different button customizations, adding a feature for combat, various player classes, and multiple other features, as well as working on designing a case for his um, display so that it can function more like a portable gaming system. So I'll turn it over to Gleb to tell you more about his project.
Yeah, hello. My name is Gleb. I'm an incoming freshman, and my project was the Infinite X Adventure. Here, I got my screen running the adventure, but it's easier if I screen share it. Um, as you can see, I one of the modifications I made was adding classes, and you can choose a class that you're going to play as. Um, and it also gives you spells. This text adventure uses ChatGPT to ChatGPT's API, the OpenAI API to communicate with ChatGPT. So it can give you different scenarios like this and different actions that you can take. Uh, this is all generated by ChatGPT. Um, Also, something that I can show you right now, but there there's also a combat system that I made. Um, we, which allows you to use your different class actions, like casting spells, and it looks for your spell book, which is also defined using your class to like make you choose spells, and there's different spell effects. Um, so that was the most challenging part and the most annoying part to make all of these like kind of effects to work with the classes. So yeah, that I got a lot of coding experience from this because it's very software heavy. Um, yeah, I mainly chose this project because it seemed fun, and also as soon as I saw it, I knew like exactly what kind of notifications I wanted. Like I saw it and I'm like, this has the potential to be like a something like D&D, like a TTRPG. Um, and I joined Bluestamp because I want to get some engineering experience. I want to have a project that I could be working during the summer. Yep.
Awesome. Thank you, Gleb. And does anyone have any questions for him?
I have a question for you, Gleb. So obviously your project utilized ChatGPT greatly, and obviously AI has been a rising technology in recent years and will continue to be a rising technology. So how has your perspective on AI changed after completing this project?
Um, I mean, I see how it's a like a useful tool that you can work with in your code instead of like helping like it can um I don't even know how to explain it. Because this project used ChatGPT as like a narrator. So if you need things like that are not preset that would like change based on the user's actions, you can use generative API. Um yeah.
Awesome, yeah. Thank you, Gleb.
Which like elements of the game are preset and not like influenced by ChatGPT at all?
Um Everything regarding classes and combat um are preset with just ChatGPT starting like combat by saying a certain phrase like roll initiative. Also yeah, and then what's influenced by ChatGPT is the all of the actions that you can take and the storyline.
Is there like a scoring system for the game?
There isn't a scoring system because it is meant to be like a RPG, like more like a TTRPG where the goal of the game is to just tell a really good story.
Wait, so like to be clear, it goes on infinitely, so like it never stops then.
Yeah, that's in the name.
Yeah.
Infinite Text Adventure. Yeah. Or until ChatGPT decides to put you in a loop, which has happened.
Okay. Yeah.
Are there any other
Um,
questions? All right, if there are no other questions, can we please get a big round of applause for all of our speakers today? It is absolutely incredible just how far along everyone has been able to come in the given room. I know we are ending right about on time. So the only thing I want to shout out to all the students is reminder we still have class tomorrow. So please make sure you still show up and you show up online. We'll be expecting to be able to see you guys tomorrow. We have some final portfolio things to do. We have some fun prizes and giveaways. So please, please, please make sure you guys are in tomorrow. To all of the stakeholders who were able to attend, thank you guys so much for attending. This demo night is a very important and integral part of the program that we have for everybody. So for whoever is recording, is okay if I ask you to please stop the recording? If you are a parent or stakeholder, feel free to stick around for a couple of minutes. Me and the other instructors will hang around to chat about anything that you might need. Otherwise, thank you guys all so much for coming down. It's an absolute incredible feat. And don't worry, tomorrow we're going to make sure your guys' documentation looks absolutely incredible and amazing to go on all of those applications, all those portfolios, all those things you guys need to show off our project for. So, thank you guys so much. Mhm. All right. I will
All right,
ask once
thank
again
you.
thank you. I'll once again ask the instructor who's recording to please stop the recording.